OSI is 7-layer architecture, with each layer having specific functionality to perform. All 7-layer work together to transmit the data from source node to destination node. So, to understand the functionality of each layer, watch the video till the end. Here we understand how sender sends the data to receiver. OSI is theoretical model, and it is very important to understand in computer networks. OSI stands for Open Systems Interconnection. This model has 7 layers. Each node talks to the corresponding layer of destination node. All layers adding control information to the data coming from the above layer. Receiver read all this information in corresponding layer. Let's take the example to understand all 7 layers of the OSI protocol stack in detail. Suppose here, sender computer wants to send email to server, say hello world. First, your email application use the application layer protocol, like SMTP, that provides the set of commands to tell the server how to handle the data. Suppose you are accessing website, you can use HTTP protocol, which sends different information to load the website in your browsers, like Chrome, Firefox, Internet Explorer, Opera, Edge, Safari, etc. In our email example, data from application layer now goes to the presentation layer. Presentation layer converts system-specific data to specific network format like ASCII. Presentation layer is also responsible for data compression, for fast transfer, and encryption of data, for secure transmission, and protect data from hacking. Now, this data goes to next layer called session. Session layer is responsible for starting, maintaining, and ending connection between sender and receiver during the data transfer. Session layer also synchronize related stream of data, like video and audio stream, during the video conferencing. These all information get added in the header. The data now goes to next layer called transport layer. Transport layer gives the reliability in the communication, flow control for avoiding congestion and fragmentation of data. There are many applications running in our computer. Each application processes use unique port number. In our example, suppose our email application is using port number 16342. We will send this to email server, which commonly use port 25. Here, we are using TCP protocol at the transport layer, which is responsible to break down your data into smaller chunks, called as segments. This kind of segment will be reassembled by TCP protocol at receiver end. All this information get added in the header in transport layer, along with the source and destination port numbers. Now from the transport layer, we will move to the network layer. In the computer network, each node is identified by unique IP address. So you can see here, sender having IP address 133.88.6.4, and receiver have IP address 152.8.7.11. In the network layer, IP protocol is adding source and destination addresses in the header and forms the packets. Network layer decide which path to choose to reach the destination based on IP address. This process is known as routing. Moving to next, data link layer. Your packets become frames for specific networks like Ethernet LAN. Data link layer is responsible for reliable transfer between two nodes based on MAC address of the source node and receiver node that is the next connected router in our example. The data link layer adds some information in the header and trailer for error and flow control in addition of MAC address. Now this frame reached to the bottommost layer called the physical layer. Physical layer puts all the frame bits in the forms of signals in the medium like network cable. Your signal can also transmit signal through air in the forms of radio waves, microwave, or infrared, which is known as wireless communication. Now frame will send to the router based on MAC address. Router modify the data link layer and physical layer for different network, like ATM WAN. Therefore, after physical layer in the router, it goes to data link layer. Router remove all data link layer information and send it to the network layer. Now router check the destination IP address in the network layer and determine where to send this packet. Router encapsulate the data with data link information of the ATM WAN. Now router sends the data to next connected router via physical layer. After that, router remove the data link information and send the data to network layer. Again, router use the IP address and decide the next path for the packet. After it determines the path, it's append appropriate data link information according to the network type, like Ethernet LAN here. Now your data reached to the destination server, and it will be available at physical layer. Now every layer at receiver removes the information added by the sender. So first, data link layer remove the information and convert frame back to IP packet. Next, receiver remove the IP header and convert packet back to segment and pass it to transport layer. Here, transport layer reassemble the segment back into the original data. It also used the port number to determine the particular application for this data. Now, receiver used the session information to determine this data belongs to which communication stream. Moving ahead, in the presentation layer recording the header, data can be uncompressed, decrypted, or interpreted and sent to application layer. At application layer receiver, application reads the SMTP commands sent by the sender, and you will get your email message at receiver. That's hello world. So now you understand all the functionality of OSI model. In the next video we will compare it with the TCP/IP model. Till then, bye-bye.